All right. How's it going, everybody? Welcome to episode 8 of Imagine, where we explore the role technology is playing in redefining creative industries. Excited for tonight's conversation around tech and system/space. Our first speaker is an architect and computational designer, leader with experience in a range of AEC softwares, technologies, and programming languages. He's also co-founder of Homemake Labs, a video game. His research work focuses on programming literacy, geometric approaches, parametric design, scripting, animation, game engines, digital fabrication, interactive technologies, and augmented reality. Building programs and programming buildings. Please help me welcome our first speaker, Matt Conway. Woo! Take it away, Matt.
Thank you, Kako. I gotta change that those bios on the internet, so it's just that last line. So hi everyone, I'm Matt. Tonight I'm going to be showing a lot of work that I do myself and work I do with my students. So I'm really interested in sort of applying systems thinking and computational thinking to architectural problems. So this is some work my students did. You can see on like a really basic level, it's like, hey, can we think about architecture in terms of these systems? A project I have them do is just animate an existing building. Shows that they understand how to like do some type of computational thinking, and they can apply this to existing architecture. Other projects we sort of work on are, different types of space morphing and 3D model morphing. And I use this as a way to get students to understand sort of multi-dimensional data structures. So you can see we do these like multi-dimensional slit scans. And this is all like, what would be equivalent to sketching if you're learning how to see in perspective. So I'm trying to, instill this idea of thinking in data, thinking in systems to my students. One other thing I like to do with that is try and replicate. It's really hard. Buildings operate on such a large time scale, and it's hard to replicate some problems you run into in the field in the classroom. But I try and do that. So on the right is it's a GIF made of a bunch of vector drawings, actually. So it's like trying to instill this idea of like, oh, when you make a facade, you have to have all these sheets for all these different panels. How do we replicate that in school without making students just like make a facade and do that kind of stuff? So, again, trying to do something at scale in the classroom to help students understand these ideas. Now, that's sort of like an intro to how I like to show and get students to think computationally. What we also try and do then is take that one step further and sort of instill different design processes into tools, right? Ultimately, we're building like super complex compasses in most of my classes. So this is like a tool whereby you give it a box and it's going to turn that box into this like, really nice curved form, always with 4 faces that can always be made into like a physical model. So, getting students to take their sort of design ambitions and turn them into tools so that they can use it again and again, and then others can use it. This idea of like attaching text and sort of geometric output. And this can be done at a lot of different scales. This is actually what we use as a sort of intro to, this is all done programmatically, by the way, we use C# for the most part. This is another type of systems thinking. I think this is sort of like the intro into computational design is this type of geometric thinking where we're taking a facade, we are breaking it apart into a bunch of panels. We have this like nice continuity between the different faces right here, and then analyzing those panels, right? So getting some data, getting some reading from that, and doing something sort of productive and not having to manually break this facade into all these panels. So these are some slightly more practical tools we do in the classroom. And then we do other, again, more sort of design-oriented tools. So this is taking Moriyama House, the massing of it, and making a tool that just gives you a bunch of massings of Moriyama House, right? So students don't have to, if they want to keep using this as a precedent, they can very quickly throw that on a site. And you can see that there's a bunch of different sort of inputs on the right over here. This is made using Grasshopper. It's a visual scripting language. And these allow students to like sort of fine tune this and control this. And again, focused on this one type of design. So encapsulating these different ideas of knowledge they have about these designs. And then, that was like a massing study. You can do the same thing with like a more detailed architectural plan. I like to point out that this one has like the dimensions on it. So it's more, normative architectural representation. I know there's a lot of AI image making right now that's happening, which I think is cool. And this is like another way to use tools, but still have it produce what we would traditionally see in architecture. This one's using like a physics engine to get slightly different formal arrangements than we were seeing previously with like the more algorithmic one where it's like set in stone. So I have students make these different types of scales, facades, massings, interiors, that sort of thing. And then they're able to like combine these tools together. That's really important. That it's not just like this single like God tool. It's like a bunch of different tools they can pick and choose and use. So that you can see here's like a bunch of those tools put together. There's a facade one I didn't show that is actually part of here. And because this operates in like an architectural context, it's super important not important, something I find really fun to play with is this idea of taking something digital and making it physical. So here is that tool that I said always has the four sides, and they can always be sort of unrolled into flat sheets of paper. And then you can nicely sort of build that into a building. This is like a quick study model. Forgive the craft on it. So it's this idea that, we're not just embedding sort of random ideas into these tools, but like there's actually physical constraints that are getting play here too. So here's that original tool I showed a few seconds ago, and this physical model that's built from it. So this is another introductory exercise I have my students do. You can see it's a very similar one to what I just showed, where they build a script. I always have them animate because it's kind of like a proof of concept that they like know how to use the tool in a way. And then here we can see they've built these models that can be made out of paper. So I always have students build these models, and this is like a pretty sizable, I should get a better scale figure in there, but it's like a 2 foot by 1 foot model made out of paper. So trying to help my students be able to build things without necessarily having to 3D print them. Because at scale, when you, again, translating what we do in the classroom to practice, you can't just 3D print a whole building yet. So we have to build it out like flat pieces of material. So that's what this is, sort of getting students to understand the imperfections that happen when you go to something physical. So there's like little moments where they can actually like cheat kind of, right? It might not perfectly fit, but they can like force it. So I'm pro that type of cheating. And then taking that one step further, I talked about that facade panelization as getting students to understand systems a little bit better. Here, they've built similar models that are built out of multiple pieces of paper, and they can get these complex forms with that. And there's even multiple systems hitting each other. And so I like the key to this assignment is what happens when these systems collide. So you can see there's like one type of panelization right here for this medial surface, and in the back there's another aperiodic piece. And the idea is that they would somehow have a relationship when they sort of talk to each other. My students actually have this final next week, so we'll see how well they're talking. This was the first assignment they did. We did this thing called a geometry buffet. We go out in the courtyard, we throw all the models on the table, you can get a better sense of the scale here. And then we sort of like analyze and talk about how students use systems to resolve conflicts within their models, right? These are not just like boxes. This is the final they'll have next week. This is where they're taking multiple systems and putting them together. So you can see here we have like a panelized one. We have this developable surface, which is just one big piece of paper. And these are chess pieces, and we played a game of chess. These pieces look a little too chess-like for my taste. I thought they'd be a little bit more abstract. So this year, instead of doing a king, they're supposed to do a piece that represents kingliness or queenliness. So I'm excited to see what they provide next week. But it's this idea, but forcing students to like build at this scale out of paper, right? It's pretty thin. These models are super light. You can throw them up like a balloon almost. I think it's a great way to like instill like a relationship between what they've done in the computer with like what they can put their hands on. Again, coming from an architectural background. I have done one small update to this assignment before. I've tried this one more time where all those models I previously showed were made of paper. I did once where they're made of mostly paper, and this is like showing that process of students laying that out, having to think and organize their stuff. But also adding other digital fabrication techniques like some 3D printing in the mix. And so that looks like this when you have some 3D printing. Let me go to the next slide, it'll show better. So you can see there are these moments where the idea is like, hopefully you can't tell where the 3D print happens and where the paper happens. It's called 2080. It's this idea that like 20% is 3D printed, 80% is made of paper. And so it's really key where they put that 3D print. So like on this one, I think did a pretty good example of the 3D prints on this doubly curved edge right here that has this nice continuity in the surface between these two things. So, in these classes, students had to learn a lot of geometry techniques, like I just mentioned, surface continuity, developability, this sort of stuff. And then by having to build these physical models, it sort of forces them to use that. And then recently we did start filming these with robotic arms to add like another system on top of this for documentation. And so that allowed us to do certain types of like continuous movement and looping between that. So, I had this interest in geometry, and that got me into computational methods and systemic thinking. And I've started using that in other ways. So recently, a good friend and partner of mine, Nate Imai, we've been doing a lot of sort of, I guess, more like architectural practice focused uses of computation. So here's a bunch of geometric methods that we have sort of used and made. And we've used these to analyze urban maps. So we're taking a bunch of geometric stuff and we're saying, hey, how can we see the city differently through these means? So you can see here, this is a map of Lubbock, Texas. We use RGB values, so it's not just a like 0 to 1, it's more of there's different, peaks, maximums. So like green, the more green it is, the more anomalous the shape is from like a pure square or rectangle. Red are super thin lots, and then blue have some sort of urban context, like they're by other things, basically. And so this is like a different way. We call it computational cartography. This is a way for us to look at the city. We're able to then like look at the city, apply massing to that, and sort of start to give numeric qualities to these different parcels. So here you can see a bunch of parcels with their like maximum massing envelope, their maximum FAR massing that they can handle as a site, and then the actual site itself. So that you can see they're kind of these weird sites that we assume developers won't be interested in. Like I said, these are in Lubbock, they're real sites. We went around and then took photos of them. And this was partially inspired by Tele Bow Wow's pet architecture, but our sort of theory is that the programmatic overlay isn't what makes those buildings interesting. It's really the site constraints a lot of the time that make these smaller buildings kind of interesting. So we actually have one site. It's located right here. You can see it's kind of a darker green blue, and that's right here. Here's a picture of it. It's right next to these train tracks. And, so we're building these tools for ourselves for practice. So like the next thing is we had the site. We're like, what are we going to do on this site? So we started building tools. This is something recently, and we're trying to publish this by the beginning of next year. We started making tools that can give us sort of like financial data about our potential architecture. So this is sort of, you can see down here in the CAD software, it's showing us the different ROIs, profit multipliers, project costs, etc. Right? So this is like real estate information, pro formas. And we're trying to make it intuitive for us to use as architects. Most of this, if you've ever seen a pro forma, it's in a spreadsheet, and that's kind of boring to look at, where we like to model things and actually see like, well, what does it mean to have like a 3-unit apartment complex, and so we can very quickly update these numbers through the model. So that's sort of our interface of choice, is like a 3D modeling environment. And then because we can like look at these iterations, we can start looking at a lot more options for this. So here, there's on the right is the boring pro forma. I mean, maybe some of you like it. It's cool. No hate. It's fine. On the left is a bunch of different options of us looking at this. Now, we did realize one sort of problem with how we were using this system is that it was only taking into account like the square footage of these different volumes, and these different colors represent different programs. But it would give us, it would say like, this is the best one. And then it would say like, this one's really great too, though. But it doesn't take into account that this one has a very different construction system than this one, right? And so the current thing we're actually working on too, it's part of the same sort of project, is being able to quickly model something and then pull sort of accurate cost estimation into that. These numbers are Lubbock based, by the way. I know most of us are probably in LA, myself included. So don't freak out when you see these numbers. But this idea that we can start assigning, like, again, going from the digital to the physical, we can start getting some physical realities as far as like cost and material quantities from these pretty simple architectural models. So, to like bring the beginning to the end, I think architecture is great if you look at it through systems, and I think computational tools help us sort of encapsulate those systems, so we can share them with friends, we can reuse them ourselves, we can make them and forget them, and it just makes architectural production a lot more fun. And I think it's fun to think algorithmically in this type of way. So thank you for listening to my lecture.
Thanks for that, Matt. That was great to see. Looking forward to discussing in a bit. So I'm going to jump in and introduce our next speaker. Our next speaker is the robotics program manager at Sphere, where he leads the development and deployment of cutting-edge humanoid robots with Sphere properties. At Sphere Properties, his impressive portfolio includes work on award-winning projects such as the James Bond Museum in the Austrian Alps, kinetic art installation at Pfizer's headquarters, captivating Google exhibits at Coachella, kinetic sculptures for Adidas, and numerous other creative tech ventures worldwide. Please help me welcome Jonathan Sager. Woo!
Thanks for
Take
the
it away,
intro.
Sager.
I'll jump right in. Did that work or no?
Yep, we're seeing your screen now.
Okay, great. Go back to full screen. Up. View. Let's try again. Slideshow. There we go. So just going to jump right in. So this is kind of an origin story, and it's project highlights over the years. So I started in the animation department at CalArts, in experimental animation specifically. And I didn't really like animating anything, so I started building camera cranes. And after college, I worked in special effects for a little while, and then one of my professors hit me up and was like, hey, I'm starting a software company that's going to make stop motion animation tools. Do you want to design a camera rig? And I was like, yeah, obviously. So I'd been experimenting with SolidWorks over the years and basically just jumped right into SolidWorks and started designing the crane that you see here. And this just became a kind of recurring theme throughout all the projects that I've done, where, if there's an opportunity to design something, I'll jump in. But most of my work post this crane has been more on the producing end. So lots of CNC machine parts. I think we ended up building about 30 of these. They're all over the world. A bunch of them landed up at Leica Studios. And from there, next opportunity that popped up was helping a friend out design some of his lighting fixtures. So taking what I was doing in SolidWorks and helping kind of get manufacturable lighting fixture design. So these were really fun projects. I did that, didn't pay very well. So I took a job at Guild, which was a design build studio, where I became a project manager. And we started getting requests from Apple to build prototypes, and ultimately ended up doing this project, which was modeled in Grasshopper. We did a single point perspective Apple logo, and then we had about, I think it was 4,000 or 5,000 of these chrome plated butterflies. And there was a custom lighting system, so it looked like they were always moving. And the brief, what Apple wanted was iridescence, and we started with this prototype on the left, where we took it was a piece of mirror polished aluminum actually, and we kind of put it next to a diffuse light doing a color chase, and we're like, hey, this looks like iridescence, whereas all the materials that were quote unquote iridescent just really looked cheesy and weren't up to Apple standards. So then we built this second prototype, and I put it in my car, drove up to Apple, presented it. They're like, we love it. Can you build a bigger one? So then we built an even larger one and kept working our way up in prototypes till this prototype 4, which was basically simulating one of the windows. And we'd sort of worked out all the manufacturing, and then that project scaled up to install in Selfridges in London, and that was kind of the inaugural kind of premium Apple Store watch experience when the Apple Watch came out. Then I had a fun opportunity to work on this Adidas Boost mobile tour, and specifically there was, I think it was 180 axes of movement that we came up with a 3D simulation. And then, well, even though I was a project manager on this, I decided to jump in and do all the CAD design because my background in kind of electromechanical design. So I designed upper right, you see all these little boxes. I designed those so that it was basically the same part, top and bottom, same part on the side that could flip over. And so that whole, the primary CNC parts for this entire assembly was really only 3 parts. And then we made 90 of those assemblies. Each one had 2 motors. And then it ultimately became this big wall, and you could wear Adidas Boost shoes and jump around on the whole wall. Would do a bunch of procedural animation, all controlled in real time. Next up, I had an opportunity to work on a product launch at Nike, where we built this kind of like circular arena, had a bunch of curved LED screen, and we made a bunch of content for it, and it just became this immersive experience where I think the product that we're revealing was new college football uniforms. So it had this like really intense kind of like drum and bass soundtrack and ended in a reveal. Next up, kind of moving away from some of the purely kind of physical construction, H&M came to us and wanted a really cool, trippy photo booth for Coachella. So I had some friends that were working in R&D at VER and pulled in the software company Notch, and basically I think we kind of piloted the first project with Notch and doing real-time graphics in this kind of more photo booth experiential. Basically Notch was, that they use Notch on a lot of the U2 tours, mostly doing graphics for big kind of arena shows and sort of these real-time visuals for artists, performing artists, music. And so we did this thing that was basically had a bunch of content generated lighting and wind fans everywhere, and people would come in and dance. And then we had a back end that could spit out a whole custom video where they were turned into crystals and shapes. And this was a lot of fun to work on this. Next up, Google came to us and was with the idea that they were going to do their first kind of custom hardware store. This is when the Pixel was coming out. We worked with Hirsch and Mann for a lot of the creative tech installations. This was in New York. This whole wall had these kind of like, I think 5-sided spinning objects, things that could on one face spell out Google, and then they could do all these animations. And there was a little prelude to eventually ending up at Sphere with this kind of spherical construction that used a bunch of tablets, and you could search content, and it had a whole kind of way of visualizing imagery on the Sphere. Next up was the Bonn Museum in Austria. And most of my involvement on this project was figuring out how to put creative tech installations into a building that was built on permafrost. And the whole design of the building was based on an airflow system and sort of insulated construction that would keep the building, the interior of the building, just above freezing. So we knew in kind of maybe rare circumstances we might dip below freezing, but for the most part during winters we were going to be hovering right around freezing. So everything that went into the building had to be rated for these really low temperatures, because everyone visiting this museum is basically coming up in ski gear on a ski lift. And so this is one of the main rooms. There's a kinetic moving screen. There are a bunch of kind of electromechanics kind of built into these various exhibits, all themed around kind of bond technology. I think there were about 7 rooms, each one kind of with a different theme, highlighting a different part of one of Bond's adventures. Ended up back at Coachella with Google to do a project with Childish Gambino. We went through a bunch of different iterations on how we were going to build some big structures to house kind of these creative technology pieces that were designed to highlight the low light capability of the phone. So we needed a dark kind of blacked out interior where we could control the light. And so we used lasers and different lights on the inside of these giant pyramids. I think you can kind of see in the bottom middle image is these were about 35 feet tall, and people would queue up and go inside. So each one of these pyramids had a different themed exhibit inside of it. And then we had a Childish Gambino's sound designer kind of do these custom audio installations. Kind of getting back to kind of robotics, managed this project where we created a website where anyone could come and basically place a dot on the digital canvas, and that would enter a queue, and the robots would basically dip whatever color you choose. The robots would dip a brush into the paint, go over, put your dot on the canvas, and then the arm would move over. It also had a camera on it, and it would take a picture and email you a picture of your kind of splattery paint dot. So we had thousands of people participate in this. I think it was up around like 8 to 10 hours a day for I think 4 or 5 days. And we basically filled up the entire canvas during that time. You can kind of see in the top left, started off as a white canvas, and by the end, it had become this kind of pointillist abstract piece. After that, I went over to, this was an interesting kind of transitional project for me. This was after the pandemic had started, in between working on that Bombay Sapphire robotic piece. I did a bunch of work for Intel. Then the pandemic started, all the Intel work kind of stopped. And I started seeing opportunities where companies were working on their corporate campuses. Everybody was working from home. So T-Mobile started this project called 5G and Me, which was at their corporate headquarters in Bellevue, Washington. And this was a kind of transition, and it was a great opportunity because a lot of the work I'd been doing was up for 4 or 5 days, up for a couple of weekends at Coachella. And this project had to be built, everything had to be permanent, essentially, with a, 4 to 5 year kind of lifespan, as far as the, the design holding up or the experience holding up. But essentially everything was designed to be up and running all day. This project was basically the kitchen sink of any software that I'd ever worked with. This was Notch, Touch Designer, Unreal, Unity, web apps. Each exhibit, I think there was about 7 or 8 exhibits. They're all run with different hardware, and different software. I think there were 35 computers running everything in the space, and all different developers. So it was a huge kind of integration lift to get all of this up, get it all working. And it was also, it was a fun opportunity because it didn't have to just work in one platform. Basically, whatever suited the idea best, we went and found a developer or a team of developers who could create that in the software of their choice. And then we brought it all together with a kind of scheduling app so that people could go on tours through the space and everything. There were motion sensors. We did a combination of kind of live queuing and motion sensors to kind of trigger the different exhibits. Kind of all themed on how 5G influenced different industries. After that, I moved over to work on Pfizer's headquarters, again, in this kind of transition to doing more permanent work. And this was about a year-long project. The kind of hero piece for the building was this kinetic sculpture. It's about 3 stories tall. It's 54 kind of rotating parts. Everything was custom built. And basically kind of spirals around. It was inspired by DNA, little bit of the Pfizer logo, but we had a lot of creative license just to kind of make something cool. And the system behind this kind of does a bunch of procedural animation and lighting work. And it's kind of evolved to, they've been plugging in different data sets and using it to tell different stories. And then I found myself at Sphere and managing the robotics program, and that's where I'm at right now. Well, not currently, I'm home, but I spent about the last 2 months in Vegas getting 5 of these humanoid robots deployed in Vegas. And that's been my life for the last 8-9 months, and lots more to come on this. I can't talk too much about it, but very, very, very fun project. And yeah, that's it.
Fantastic, Sager. Thank you for that presentation. So now I'm going to open it up to conversation. So like Matt, you've seen Sager's talk. Sager, you saw Matt's talk. If you have any questions, like this is the part where we just talk about work, process, programs, all of the above, the future, really anything.
Well, I think my first question for Sager, it goes at the very beginning of your talk. You said you didn't like animating.
Yeah.
I'm curious if you can elaborate more on that.
Well, I had a funny trajectory at CalArts where I started in fine arts doing sculpture. And while I was in fine arts, I basically did all kind of more sound design with algorithms and kind of trying to design different kind of, I worked in Kima as, object-oriented programming language, and basically wanted to create things that I could just like put sounds into and would constantly evolve. And I didn't, at the time, this was, 99, 2000, there weren't a lot of, or at least not on my radar, a lot of really interesting kind of procedural animation tools. So, but I know I wanted to make things move. So I left fine arts and I moved to experimental animation, and didn't really want to do stop motion. I liked miniatures. I still to this day photograph miniatures, but I didn't want to actually like tediously animate things, and I didn't like drawing, doing hand drawn animation. So I was like, well, I can design a machine that can move, and in the CalArts scheme of things, that was totally passable in experimental animation. As long as I was making something move, it was animation.
That's fair. I don't know if
Yeah.
that's a commonality we have that Kako knew about before pairing us, that we're trying to animate stuff that maybe doesn't want to be animated. It doesn't naturally kind of.
I could sense it, I guess.
Yeah, the robots we have at Sphere, how many? I think they're close to 100 axes, brushed DC motors. It's a lot to wrangle when you're trying to design animation tools, and
do the robots at Sphere. It's interesting. So all day today I was on a mid review of an architectural studio, and they're like redoing the Sphere in Vegas, and a lot of it was just talking about the experience and the relationship between the physical form, like in this case the Sphere, and like the digital media, and like which if the physical form still matters, or if digital media is just so powerful it supersedes it. So I guess my question for you is, do the robots have, like, what's the relationship between the robots and the actual, like, the giant Sphere? Or if you can talk about it.
Yeah, no, I don't think there's any relationship between the robots and the Sphere itself. I think in broader terms, there's been initiatives over the years at Sphere to develop innovative technologies. So the Big Sky camera that they designed, I think it's 18K by 18K. It's basically the highest resolution, biggest format camera in existence today. So the robots fall much more into that category of let's kind of do something crazy with technology, and kind of just letting the public loose to hang out with robots is kind of more on that tip than the architectural Sphere.
Sure.
Yeah,
that's fair. I'm looking at my notes. I was taking notes at some time. I have one practical question, or maybe I missed it. The Bombay Sapphire. How did the people decide where their dot went? Was that like just a web browser?
Yeah,
they could jump in, so from anywhere.
Yeah, you could kind of zoom into this big digital canvas. So it was a website, and so because it was an alcohol company, I think you had to say something like you're 21, and
Sure.
then you could go in and you could basically kind of move this digital canvas around, and then you could pick a color. So there was a little color wheel or a little color selector, and then you just click and
do it.
Yeah.
I'd love to see the interface. I like the idea that like you could have made. I don't know how it looked. I guess I want to see the interface because I'm curious, like if you knew you were doing something physical or not, and like how fast, like how fast that turnaround was. It'd be cool to hear the people's experience of doing that.
I'm trying to remember what the turnaround was. I think the turnaround from getting an actual image, I think the queues sometimes got really long, where it could be up to like 30 minutes or an hour. But we were streaming the whole thing. So the first thing you saw when you came to the website was live video of the robots painting.
Okay.
So it was streaming video of the actual painting happening in real time. And then you would click into the digital canvas and place your dot. So you had some kind of contextual awareness at the start of the experience before you kind of went to the digital canvas and, put a brown circle dot, which, we modeled it so they kind of look like paint splatters, but, it's still a digital representation.
Sure.
And that whole project, I think, was done in a little over a month. I think it was 5-6 weeks. extremely fast turnaround. So a lot of the decisions were just kind of like on the fly. And
No, it was cool.
Yeah.
It was cool. I'm surprised, like, one of these like internet phenomena of like people like joining forces and like making like an orange square or something didn't happen. It looks pretty well behaved as far as people stayed in their own little areas.
Yeah, for the most part, yeah.
Kako, can I ask you a question too? About
Yeah,
are you
sure
part of this
thing.
conversation? Okay.
I'm a part of I'm talking here too.
It occurred to me, so we've been talking about like animation, algorithms, robots, right? Physical, digital, but isn't this series on AI?
No, the series is just generally technology,
Okay.
technology and how it affects creative industries.
Okay.
But a lot of the topics have like danced around AI.
Sure.
Or because it's like very topical right now. A lot of people talking about AI and the tools that are coming up. And go ahead.
No, my question can wait. I won't forget it.
So I guess I have a question for both of y'all, since you're both working at like this with like technology. You're kind of you're both very comfortable with tech, and there's like an artistry that you're afforded when you like your medium is technology. You can kind of like think it, see it, invent it, and then just do it. How do you then communicate that value back to clients? That because you're working kind of in this like dream realm where it's like I can invent things, watch me. But then you have to talk about how like it's going to bring someone value, or it's like good in some sense. How do you do that with something that doesn't exist yet?
I mean, there's like the basic, like there's an obvious like ROI in like a practical sense, right? I found with the students, they jump into the new tech pretty fast because I think it's just something new and like it's a different way to think. And then I think what's kind of interesting is to see which ones stick with it then after that class, right? There's like a lot of classes they can take. And so I don't know an answer, but this makes me want to ask those students that it's stuck with, like, why did you stick with the tech? Or, like you saw the value in it. Why was it through use? Was it, a problem you were solving? I don't know. I think this is great. Let me think for a second. I'll let Sager talk.
I'm just thinking about like even software that I've left long behind. I think any experience with software kind of informs a lot of decisions you make, whether it's new software you're working and having awareness of procedural tools or object-oriented programming. I think whether you're actually I don't really do code anymore at all. I'm mostly managing projects, but having worked with those tools in the past, it definitely kind of informs like my thinking about projects. And if I'm looking for help or I see an opportunity to bring somebody in who has a skill set, I sort of have at least like a direction I can point myself in. And I don't know, Kaka, I feel like we've kind of veered off from your question.
No, this is great. We're just chatting here. Like, this is what I want. Like these conversations, whatever you're thinking. Really, I'm curious about, because y'all do so much, and I'm invited both of you because you sort of inhabit like whatever work that you do inhabits like environments. Like it takes up space. You got here, like both of you got there in like from a different path, and your approaches are different, but also like hearing that like there's this through like secret underlying through line of animation. Like so then now that maybe this is an easy question. It's like now that you're here, like what's like the next move, since both of you seem to be always like searching and like doing different things. Is there anything that you're interested now that either didn't make it to the presentation, or it's like, this is on my like top of the list, like I got to learn this next?
I can think of a few things, just like thinking about the arc of stuff that I've done in the last, I don't know, 20 years. I really want to get back to a lot. Like there was a film I started at Cal Arts, I never finished it, and the idea behind it was um, it was going to be motion control marionette puppetry. And so I had a friend, there was a funny point in my life where a bunch of guys that worked in motion control in Hollywood all had excess gear, and they all gave it to me because I had a big loft downtown, and I'd sort of amassed some machine tools and had a little machine shop. And so I built this, I took this old crane arm and I put a marionette puppet on it, and I figured out all these kind of levers and gears, but it was an absolute nightmare to program. I was using Cooper, which is 32-axis controller, but really designed for moving cameras. I want to get back to that idea of kind of controlling, using machines to control movement, but of nothing that you would expect to be moving.
Dude, that's genius. A marionette controlled by a robot arm.
Yeah.
You're like giving it a body in a different way.
Yeah, it was like I don't know, there's, I think, 800 pounds of lead as the counterweight on this arm. The one I was using that I put a marionette on was built for, I think, the first Star Trek movie. They built one for Star Trek, one for Star Wars, and then I think there was like a third one they built later in the 80s. But this one like was just this hulking monstrosity of metal.
Yeah.
The track that it went on was like 16 feet long, and the track itself weighed like 700 pounds. It was a beast. And then it had a little marionette of like this 4-legged creature that I was trying to make it walk with all these different levers and, you know, thin wires. And every time I built this big sand desert landscape, and every time that I would program it to walk, the sand underneath its feet would move. And then when I went to replay that move, then it's the sand that all moved, so then its feet wouldn't connect, and then it would just sort of flop around. So proved to be really challenging, and I'd like to distill that down and do something simpler, kind of animating, you know, inanimate objects, but in surprising ways.
You know, it was funny. You know, all the AI tools have been coming out, right? A lot of them. And the first time I sort of really wanted to like jump into them, other than just like understanding and knowing them, was I was like, oh, you could probably do some hand animations, you know, remove some of these efficiencies, because like you mentioned, it's a lot of work to do any type of animation. It's a, you know, it's a very like labor intensive craft. And so I was like, I started becoming curious as to like, what parts can you know, can you still keep the artist's hand in there, and what parts can you sort of automate in a way where like animation could be more like disseminated, like someone without a studio could like do it quickly. Because I took an animation class in high school, and I made like a person walk, and that was like all semester, right? And so it's like, I know how tedious these kind of things can be sometimes. But it, like towards that a little bit, this is something I've been wrestling with a little bit, and maybe Sagar, you can answer this in this question I'm going to ask you, which is, you mentioned you're into miniatures. Is it more fun to paint miniatures, or is it more fun to program a robot to paint miniatures?
Yeah, I think that's on that level. And I used to paint Warhammer figures when I was in like 3rd grade. So I would say it's more fun to paint figures. I think like where automation comes in, I think is, for me, is when there's more kind of like ergonomics and system design that moves things, rather than having to be really tediously keyframing and doing it kind of in a more traditional animation way. Whereas if things just move, or they're reacting, or there's sensors, or there's something procedural that's controlling their movement, that to me becomes interesting on the machine end. But then I programmed camera cranes on like a postal service, or it was a camera head to do like a postal service video, and it was a nightmare. I was like, never again am I going out on set and having to program something, with a whole bunch of people around waiting for me to get this like camera move correct. I was like, no, never again.
Yeah.
So yeah.
What if it was a procedural painting of we'll use Warhammer?
Yeah, that becomes more interesting. I'd much rather, and this is the same thought when I was doing more sound design and music, was like, if I can craft the sound in the system to just do interesting things, that to me is, I want to be able to, I enjoy watching projects and work that sort of can have a life of its own, or can do things without, with some autonomy. I think that there's a lot of creative and technical thinking that goes into that.
Some non-player games. You just watch it happen.
Yeah, I'd much rather watch somebody play video games than play a video game, to be honest. I'm more on that end.
It's kind of, especially if they're like riding horses or something. We just streamed like Zelda Breath of the Wild. So I'm gonna open it up to the audience. We got some questions that are being asked. So this one's coming from Maya Flores. What advice would you give to architecture students who may not know what avenue to go down with their future? I'm going to pair that with another question that I think also has relevant here. So it's like, what advice would you give? But then also from Kevin Boyce, so many programs out there to learn. As someone who wants to integrate architecture with AI/digital space, what software would you recommend I try and learn over the winter break? So really like advice you give on learning this stuff and integrate it into your practice, because it sounds like y'all know a lot of stuff. And we saw some of Sager's like origin story, but like, and you started from somewhere that like, looking at your work, it's like, I wouldn't have guessed. I didn't know that you started with animation, like an angsty animation student. It's like, I'm gonna do everything but animate. But then you ended up here, which is like kind of incredible. But like, how do y'all start? Like, where do you even begin to learn any of this stuff?
I think it's always helpful to start with like a project that you're excited about in general, and then use tech in that project. Like when I started coding, it was just in Studio. It wasn't like a class, like this was back when like they didn't have coding classes in Studio. It was just in Studio, and like I said, I was trying to animate architecture, and so I like learned how to code so I could animate the architecture. And then since then, as Kako mentioned at the very beginning, I now am a partner in a video game firm, which I didn't talk about today, but like I think it's cool. One thing that's really I've enjoyed about code is it transcends a lot of different mediums in a way. Like I use like the same coding practices in video games and in architecture. So, and I get different types of joy out of both of them. But they've helped propel both also, which is really cool. As far as like specific AI programs, I think I would almost learn like how to connect to AI API so you can like bring it into whatever program you're trying to do. I think that's probably the most helpful thing, because those models are changing like constantly. So instead of focusing on like which AI model, figure out how like, hey, how can you, I'm assuming you're using Rhino as people do in school. How can you bring that AI in a Rhino environment? That's my advice as such.
I guess my advice, and I may interpret this a little different because through my own lens, but I from college through kind of my early projects, I did all kinds of stuff. I took photographs for magazines. I helped produce events. I worked at PR companies, writing briefs on, I worked on something for Nothing But Nets and the UN Foundation, writing about like how to, what kind of marketing could be done to people to bring awareness to malaria in Africa. And, I've had lots of opportunities to travel around on projects. And I think all of that brings in an awareness of a lot of the physical elements of projects, being aware of space, being aware of people. Always, there's always a technology thread to the projects I've worked on. But grounding things in experience in the real world, even just knowing like how something is going to be photographed, and what's the difference in lighting for a photograph versus lighting for the experience in a space. They're very different. If you think of how a film is lit, like, none of us are lit like it's a movie right now, because movie lighting is very artificial. And like, if you're ever doing like a photo booth, or you want to make people look really dramatic and amazing, like you're gonna lean more into kind of film production techniques. And so having all awareness of how all these things kind of can work together gives you more tools and more like a broader mindset to bring to projects. And even if you're doing something that's purely digital, I think there's always a person on the other end of the screen who's in real space. So I think just the more awareness you have of space, and the more kind of diversity of experience you can kind of have. I mean, my mentality has always been like, just say yes. If it's a cool project, if it's going to be challenging because it's something you've never done before, but you have the opportunity to say yes, then I've just like, dive right in and do it. As far as AI software goes, I would agree. I think a lot of, if you're working within, I mean, there's just so much work getting cranked out in this sort of AI platforms, whether that's, Midjourney or Stable Diffusion, or, anything in the OpenAI ChatGPT world. And it's like, it's really the edge cases where it's being used in interesting or novel ways. It's like, figuring out where, consuming a bunch of what's been out there, what's already out there, and looking for unique opportunities to use AI in a way that maybe it hasn't been used before. To me, that's really interesting. And it's, what's a problem that you could bring AI into and maybe come up with an interesting solution, or create an interesting aesthetic by, subverting some norm where something is not normally, where AI wouldn't normally come in.
It's kind of been an overarching theme from a lot of speakers. They say similar things. It's like, all this AI stuff is great, but just don't use what it spits out. Like, you gotta remix it, you gotta sample it. Some more music references in there. Sagar, I didn't know you also made some music. That's another through line here, because Matt also makes some music.
Oh yeah. Yeah, I've gotten back into music. I've been playing these weird flutes, ceramic flutes lately.
That's cool. Is that like you're collecting flutes now? You're collecting rare plants and flutes?
Yeah, I got book collection, plant collection, some flutes. What other weird? And then we talked a little bit about miniature. I've got tons of camera lenses. Been collecting camera lenses for 20 years. So.
Oh, that's awesome. That's right, because you do like micro photography.
Yeah.
As well. I put that on the list. So we've got time for one more question. I guess this sort of dovetails into the conversations about like AI and the stuff that's being generated. This one's from user Makuro, with the O spelled with a 0. Does anyone find that the hyped AI image generation to be detrimental to their creative process?
Wait, was the question, is the hype detrimental to the creative process, or read it again, Kako?
I'm gonna read it again, but I want you to take it as you will. Like whatever you think is the question, let's answer that. But does anyone find the hyped AI image generation to be detrimental to their creative process? Wherever you want to put the emphasis on. I can read it with an emphasis on. Does anyone
I-
find the hyped AI image generation to be detrimental to their creative process?
Yes,
Um,
I caught a glimpse the other day of Wes Jones' article, and it was titled like "The Delirium of AI in Architecture." And I'm sure it's going to say
yeah,
it's detrimental.
yeah,
Uh, it's I don't know if I want to say it's been detrimental. I've seen some students use it really well, and they've come up with stuff they wouldn't have otherwise. I've seen other students just like today, there's a great example of someone who just like accepted what it gave and like didn't, question it. One thing probably the most detrimental thing I've noticed, I don't know if this is just necessarily the AI part, or I think there's also a culture of feeds, like everyone today just is on feeds constantly, where like the search engine is taking a backseat in a weird way. But maybe AI is bringing that search engine mentality back to the forefront. But I've noticed that, and I don't know if this is an AI thing, but students don't know references as well as they previously would, which can be good, right? References can hold us back too, in a way. So I don't know. It depends. Yeah, someone finds it detrimental. I don't know if that's me. I'm pretty open to it.
Yeah, I'm I'm totally open to it. I don't know if I like want my Instagram feed just to be entirely full of AI generated images. It gets old real quick. But as a tool, um, I think when people use it as a tool, it can generate some really amazing results. When it's people's exclusive tool, I don't know how much really interesting work is being done when that's all people know how to work with. I mean, obviously, there's some amazing prompt crafting going on out there. But one example, when Stable Diffusion came out, I happened to be working on a project for Davos where we were animating. The whole theme was these like crystals and bubbles, and we used Stable Diffusion to come up with like a bunch of different ideas on how we could kind of transition between crystals and bubbles. And so we spit out all these different things, and that ultimately went back to the 3D animation software for different ways. And so we used it as like, reference and an idea generator. And I think it's used in that capacity. It's just one example, but there's all kinds of other ways to use it than your final output. Just coming up with really high resolution inspiration imagery that you can then 3D model, or it's a great sketch tool, especially at the fidelity you can get out of it.
yeah, fantastic supplement to like a creative process. And yeah, I agree with what y'all said. I don't know if it's like the whole thing, because it's like AI image to, and then you've got to do a bunch of other stuff after you make the images, like unless the goal is like let's just make a bunch of nice images. I think we all need more weird books. I think that would be great. Those are also fantastic for references. Well, we're at that part of the night where I gotta say, fantastic conversation. We've got to end it. All good things come to an end. Wish this conversation could keep going. And really, thank you both for taking part in this. Seeing your work was fantastic. Insightful conversation. Thank you again for gracing us with your time. I wanted to see if y'all have any closing comments before we say goodbye and good night.
I mean, I'm glad you put this series on, Conway. It's great. It's great seeing everyone.
Yeah. Oh, my pleasure.
Yeah.
Hopefully we'll hang out IRL next time.
Yes.
Yeah, it's been a pleasure.
All right, y'all. Thanks for everything. And that's it for Imagine episode 8.